Good afternoon. My name is Steve Whittam. I represent Whittam Associates. Whittam Associates has been a support arm of Autodesk for the last 35 years, primarily working and consulting and training with woodworkers throughout North America. Through our presentations, seminars, and webcasts, it is our hope that you will see workflows and different methodologies that could assist your group to become more efficient utilizing the tools that are available to you today. In our sessions today, we'll be using Inventor 2020 as well as Woodworking for Inventor. If you have any questions or concerns, please get in touch with us either by email or by phone. In our first session, we developed a solid body model that is close to what I'll call the finished dimensions. The intent is now built into this model. It's very changeable. We use logic, at least in development of the form, so that it's very customizable still and adjustable. Thusly, if we have clients or architects or in-house staff that need to change things, they need different spacing for each of the openings, we now still have the ability to very easily and quickly change it. But again, it's not done. It's just the first step. Some people will actually create working drawings from this. They'll create detailed drawings from it. But we're not going to see joinery. We're not going to see doors and drawers in it. You're not going to see pulls in it. You usually don't see pilot holes. If I'm going to dowel this together, I usually will not do it here. Shelf pins, I will not do it here. Again, the concept of solid body modeling for some, and in my opinion, of course, is that it allows us to really think through the design, take a look at the different proportions, and adjust it until we get to whatever the needs are of our client base. Also, if this was going to be a family of pieces of furniture, how will this look when it's this much wider, this much taller, or deeper? So all those things are very easily done at this stage. But of course, we need to be able to move to the model on the right-hand side of the screen. The model on the right-hand side of the screen is quite a bit different. It has grain and grain direction. It has materials, different materials. It has hardware. It has doors. It has shelf pinholes. It has joinery. It has quite a number of other unique attributes that, of course, we need to go to. So if I come over here and let's just move it around a little bit so we can see what's going on. There's a lot of detail in here and a lot of fits, a lot of things that have to fit together. So again, these are the things that we definitely will need to go to. The drawers themselves, okay, to what level of detail we're looking for. Do we really need to show dovetails? Well, if we do, fine. We will. Doors and shelves, easily placed, hinges and the like. So what we're going to do in our session today is to take the existing solid body model and turn it into an assembly and associate materials to it, grain and grain direction to it, and then add some joinery that we can use as a template for anything else we might want to work with from this point forward. So our next step is to start working on the solid body model. I'll maximize my screen so we have just a solid body in our system. And of course, our dialog box here, our iLogic system of forms, of course, is still here and it's still fully editable. And it will be editable after we're done also. So the most important thing is to realize that every part in here is a unique solid. And if you move your mouse over to the left-hand side of the screen, you'll see something called solid bodies. And in this particular situation, this model, I have 14 solid bodies. And the first solid body is the skeleton. We talked about that last session. And what we have here, of course, are the individual pieces. So, for example, the top panel, the left panel, and I name these, okay? I named each one. Many ways to name it. You can click it once, click it twice, and just type in whatever you would like to name, or right click and go to properties and type in the name here. Now, normally, if I'm using Vault or other document control systems, these names would be a little bit more elaborate. They might have a project number like 901 dash right panel or 901 underscore right panel. And depending upon the CAM system you're using, sometimes CAM systems do not like to have dashes or underscores or spaces in their name. So you just have to be careful in what you're naming it. And of course, the whole purpose of that is they would be unique. Everything unique to the 901 project, 902 project, or whatever numbering or naming scheme you might like to use. Obviously, if it goes into Vault, they have to have unique names, and that's why I'm suggesting some sort of methodology that you come up with that will allow that to happen. Everything here, if I right-click on something and turn the visibility on and off, you could see that visibility is on or visibility is off, and you can see it's grayed out at that point. So to turn this into an assembly, simplest method is to be in the Manage tool, go to Make Components, and Make Components will allow you to turn solid bodies into parts. It's asking you to select which items you want, and I'm going to pick that, and you can see I can pick it individually, or I can go over to the browser, hold down the Shift key, touch the bottom solid, and all of them get selected. It's going to ask you some questions. For example, it's going to name it, if you so desire, the same name as the part, the solid body part is. It's called Furniture Master, IAM, where the part was called FurnitureMaster.ipt. Next thing it's going to ask you, of course, is where do you want to place that data? So, you can go into the workspace, you can go into a folder that you want to make sure everything's in, and pick Save, and you can see that it's now within that particular folder, or will be in that folder when all the files get created. I'll pick Next, and what we have here is the Make Component dialog box, where you can see the body names will now become part names, and if you can see the name of the body will then become a part name ending in IPT. I do everything beforehand because it lights everything up and you can't tell which is which from this environment, but you can come in here and you could change the names if for some reason they don't make sense. You can just type in whatever you like. And of course, what templates you're using and BOM structure, for the most part, is always going to be normal, because these parts are going to be machined. They're not purchased parts. They're not phantom parts, at least in my world at the moment. I am going to not do anything on scale or mirroring, so all I have to now do is pick OK. And what I'm left with, if we take a look here now, is it looks very much the same, except that it's now an assembly with all the parts already highlighted. So if we now looked at it, okay, and I'll say I want to do vertical tiling, you could see that this is the original part, solid body part. This is, of course, the finished product. And this here, of course, is the assembly. I'm going to just close this guy here. And now what you're looking at is a part file with solid bodies, an assembly file. And I'm going to pick Save now. So what this is doing is it's saving. It's saying its initial save of all those parts. And I pick OK. Now they're still associated together. So if I want to change the assembly width to 55 inches and then do an update, of course, is changing. Okay, and there's all kinds of methods of embedding the master solid body part into the assembly, so only one file is opened. Okay, so let's go and look at this now. So what's our next steps here, okay? Our next steps are, at this point, now that it's saved, is to apply material to this particular model. When we reach this level of assembly, normally the workflow that I adhere to is to now start adding materials to the components or the new parts that have been created. Rationale is I want to start seeing differentiation between different materials. I want to see grain and grain direction of those materials. I want to segregate things out a little bit. I want to start looking at the reality of what this might really look like. At the same time, I want to start developing my cut list and my bill of material automatically from it. The usage of Woodworking for Inventor, which of course is what I presented right up front. If anybody would like to download it, it will run for 45 days. Once you start using it, you'll see that many people who started using it, who are Inventor users or new users, saw a dramatic increase in capability of time and precision. And you'll be the judge of that if you decide to go in that direction. So we have menus at the top of the screen, and the normal menu is the Inventor menu, of course, but at the end is the Woodwork Design menu. And in last session, we talked about the skeletal menu that is in a part file. We're now in assembly, so it's a little bit different. And the first major area here is materials. Okay, and our materials are split up into different categories. So if I pick a sign, this is a very condensed dialog box. And if I pick this pull-down menu, these are the different materials: solid boards, laminated boards, multi-layer boards, desktops, and so on, including veneers and edge banding. These are all the things that most woodworkers need to assign materials. And of course, we can do metals also. Solids, of course, are hardwoods and softwoods. Boards are items that you purchase. Sheets, like glass is in a sheet. MDF is in a sheet. All kinds of MDF with covering, melamine, and so on. Okay, so all of this is categorized. So if I pick a board, for example, you could see here's an MDF board, here is some glass, here is plywood, and you'll have code numbers or code names and material names, a code name and a descriptor. All of this is adjustable so that your cut list will actually present back to you correctly with exactly the name of whatever the materials are you're using. So even though it is set up out of the box with predefined information, that could either be deleted or renamed to meet your particular requirements. And in fact, you can change the coloration, the grain direction, and everything else so that you can standardize the way everybody works. And that's one of the benefits of using these kinds of tools. So let's say that everything here was made out of MDF. I'll pick apply, and because I didn't select anything, everything there is MDF. If I now say that I would like, and the MDF doesn't have a covering on it, as you can see, it is the same throughout. Let's say that I want to assign a laminated board. A laminated board, you could see, is a little bit different because the laminated board will be a core of whatever, and then a covering or the outside veneers of something else. So let's say we buy quartered oak. That's down here. So quarter oak on a high density flake board. Okay. And I'm going to make the left vertical and the right, all the verticals, that material. So you can see how quickly things change. And what's interesting about this is you see a core of one color and a covering of the other color, and also you see that two different sides. Okay. Now, if you want to also say that I'm going to put a different type of material in this laminated, let's say laminated board on fiberboard, and it's a different color, we can do that also by just, let's say, let's say the back, and I'm just selecting everything else that's left. Okay, so within seconds, you can see what we've done. We start changing it up immediately, and I'll pick save to save my work. Everything you can go back in and pick again and change it again. Okay, so it doesn't really take too much to accomplish this particular task. So we pick save and save our work. And normally the last step in the process is to apply edge banding to the part. Obviously we're doing this because all of this downstream will show up not only in drawings but bills of material and cut list. And the goal is to make it very simple and to standardize the way everybody works. So I'll say assign. Let's pick some edge banding. Let's take a look at the whole dialog box. I'm going to pick this PVC edge banding. The name of the color will be this. And again, this is all adjustable. And when I place it, it's asking what is the thickness of the edge banding, okay? So obviously we can add any thicknesses we want, metric or imperial. And when we apply the edge banding, we also have the ability to say if I want to edge band something, when I edge band it, the edge banding will sink into the surface of the material so that I am not adding thickness, I'm removing thickness from the panels themselves. Or I could do it the opposite way by clicking on this button, and now it's going to sit on top, adding to the width of those units. Okay, so once I've selected the one I want, then I'm going to just touch a face, and you can see touch a face. It found tangent faces. I'm going to touch 1, 2, 3, 4, 5, and 6. Let's get this guy here, 7. Okay, and pick apply. I now have it edge banded, and I'll pick save. So quite quickly, we're generating this information. Now, if I went out to a bill of material, everybody saw how I did it last week. Notice I have the names of all the parts, the quantity of the parts, the length, the width, and the thickness of every part there. And if I change it, then of course the bill of material or cut list will change. Now this is an internal environment, meaning this doesn't print at the moment, but if I want to go to Excel, I pick Excel, give it the name of the file you want, and this gets all reported back to Excel. And here in Excel, you could see that we have different tabs at the bottom of the screen, and you're going to see that this is the name of the assembly, Furniture Master. Here are all the parts, their length, width, thickness, codes, the names, and everything associated with it. If I want to look at all materials in summary, you could see that I have boards that are MDF, that is 3/4 of an inch thick, and this is how many square feet. How much laminated boards, 3/4 inch, 2 types, oak quartered, and this other FO2 color. And in fact, all the edge banding, I got 27 inches of edge banding. Now this could also be displayed in metric, it could be displayed in feet and inches. So the point I try to make here is that this is all going to happen for free. If I hit the plus sign, you'll also see the right panel is made up of laminated high density fiberboard, how many square feet of it, and also how much PVC edge banding there is. And you can also see that the board is 38 and 31/32 wide, but with the edge banding added, it's 39 inches. So all of this is being adjusted and controlled just by a single pick. Now we'll be talking about bills of materials, cut listing, and the like, I think in our next presentation. So I'm not going to spend the time today to go over that detail, but there's no reason why we could not accept this as just as a start point to work with. Now, grain and grain direction. Another important facet, because whatever I do here should go directly out to the system and tell me what the grain and the direction of the grain. It should note it. It should tell me what edge banding is on it. So let's take this left panel and change the grain. I'll pick grain. I'll touch the panel, and I'll say I want to align it to this edge and pick OK or apply. The grain just changed. What's interesting about doing that is that now that information is quite important. It'll show up again in a document showing that that is what we need for that particular part. The shop will see that. In fact, if we send this out to different types of camp systems, the camp system itself will know that the grain has changed, and if you're nesting, it'll turn it into the correct location in the nest without any operator intervention. So what you see is what you get here, and that's one of the major benefits. One more area of interest before we move into joinery is that we can do what is called automatic plotting, either of the whole assembly or individual parts, or both. So I just opened up that panel. The grain, of course, is running the short way, and the standard is the longest side is the default grain direction. That's why the grain is always running along the axis of the longest edge. But again, as you can see, we've changed that. If I do something called autoplotting, autoplotting will take whatever you see on the screen, pull it apart, dimension it, and tag it for you. So whether this is 1 part or 50 parts, the output capability is dramatic. So what it just did automatically is it created a sheet of paper. It created as many views as you wanted automatically. So it created a face view and a side view. It showed you the grain direction with the arrow. If this was non-shaded, it's still the grain. It shows you the edge banding that you applied, and it's also showing you the edge that is noted where the edge banding is, and it also dimensioned it for you. This is one stop. It also told you the size. If you notice here, the part size is 26 3/4 by 15 1/8, but because you had reverse grain, it reversed the workpiece size. So again, that's what's telling many of the other systems that there is a change in the environment. It also tells you this, tells you the size and everything else that is necessary. And of course, this could be your own title block. Okay, I'm not going to spend time. This is again for next session, but just wanted you to get a sense of, capability from starting with solid bodies and now moving into assemblies. The core of our presentation today was looking at the workflow to create joinery for any type of woodworking project. But it doesn't necessarily have to be wood. It could be really any type of material. When we start out designing, sometimes we don't know the joinery we're going to use. Sometimes the joinery is an essential element of the design, something decorative. Dovetails are decorative. Finger joints are decorative. Japanese joinery is decorative. And we want to show that if we can, sometimes by mixing materials, so that end grain shows up differently than face grain. It's more of a contrast. Or maybe what is the joinery that we determined we are going to use is going to be based on the type of construction. So for example, what if it's knockdown? Has to be able to be assembled or disassembled. What if it's more antique or mission furniture style? Okay, that's something else that you might consider through tenons and plugged or pegged dados and peg tenons and so on, and haunch joints and the like. Maybe it's structural. Lots of different rationales. Maybe it's post-slammed. or pre-lammed, and then you have to consider different approaches. So at times sometimes you just don't know. So you do the best you can. Now the workflow that I'm suggesting, at least one type of workflow that we adhere to, is this solid body modeling. Why? Because everything's butt together. Okay, so if I just rotate this panel on the right hand side, you can see everything is just butt together, so there's no joint. Maybe it's going to be dowels, maybe it's going to be biscuits, maybe it's going to be, you know, a slip tenon, maybe it's going to be one of the new knockdown fittings. I don't know yet. But if you sort of lock yourself in at the start, then it's going to be much harder downstream to develop changes. Obviously, if this was a catalog environment and you knew exactly what you'd plan for it and you're done. But sometimes you just don't know. Someone says, okay, we're going to switch from biscuits to dowels because we just got a dowel inserter. It's going to be more efficient. Okay, how do you do it quickly? So everything that I'm doing here is meant for change, and I've always adhered to the philosophy of build for change. So when it does happen, it's not a surprise. It's expected, and you can get yourself out of trouble within minutes, not hours. I want to go home at 5 o'clock. I don't want to find out at 4:30 I got 3 more hours because of somebody changing something on me. So my goal today is, first I'm going to show you the end result of what I'm suggesting as one alternative, only one, and then I'll show you how I did it. And that way you can get a much better sense of construction, and hopefully you can carry it out on your own. Now everything I'm doing here, we're more than available to send to you. Any of these parts, any of these pieces, the assembly, just email us and definitely we'll have it over. So if we take a look at what I've got here, okay, I'm going to want to put in a blind dado. Okay, but you can see that these are all flush. There is no blind dado here at all. And of course there is no cutout for the tenon that's going to fit in here, or the back of the dado that's going to fit in here, and I don't even know how deep it's going to go yet. So I've got location, size, offset, all those things I just don't know. So let's see how we're going to do this. I'm going to take the right hand side and turn the visibility off. I'm going to take the left hand side and turn the visibility off at the moment, okay? And I'll take the back and turn the visibility off, just so that it's going to be clearer to see what we want to do. So we have 3 horizontal boards. If I measure them, this board is 53.5 inches. Okay, that's what it is. And this board is called test top panel. And if I went to a bill of material, the top panel is exactly 53.5 inches. Okay, so we know that's good to go. So if I'm going to place a dado, a blind dado, I'm going to have to add material to this. And if I add material to it, then the bill of material, the cutlass, has to increase. Okay, 53.5 is our magic number. And the depth of this is exactly 15 1/8. Okay, so knowing that, how long of a dado do you want? Well, do you want 12 inch? Do you want 15 inch? Or maybe you want to be 2 inches back. 2 inches back from the front. Whatever you make, whatever decision you make. So if it's 2 inches back, it'll be 13 1/8. Okay? So we have those 2 magic numbers. Okay. Now, how do we do this? One of the methods that we train companies is to create templates. Templates are very, very helpful because they standardize the way people work. Even if I'm just doing the work myself, it standardizes from one job to the other, and if I get good at it, it becomes, pretty straightforward every job from that point forward. Or if we have multiple people, then everybody does it the same way. Isn't that nice? Everybody building the same way 3D models, or close to the same way. That way I can take somebody else's model and immediately work on it. Okay, so I'll go into Create. It's asking me for the name, and I'm going to say, let's say it's Blind Dado. I'll say it's, first of all, project number 901-B Dado. Okay, 901, prefix, so it's unique to this job, no other job. Okay, where's it going to go? Well, obviously it's going to go into the same folder. Is it a normal part? No, it's going to be a phantom part. And the template I'm going to use, I created a folder called Tenon, and I'm bringing in the variable dado. I pick OK, and I'm about to place it somewhere out here. Doesn't matter. Immediately a dialog box pops up asking you, is this correct? Is this the correct size? Well, no, it's not the correct size. The material thickness, which is this thickness here, yeah, that's the correct size. But if it wasn't, let's say it's 1 inch, then you can see the dado increase to 1 inch. Well, I wanted full width, so that's 0.75. Okay, next. The dado depth, that is how far into the board, the side panels, it's going to go. I'm going to change it here. So if I was going to come in a 1/2 inch, 0.5, it's now 0.5. So I'm going to control it now. Or what's interesting about this is I can control it after the fact. Once it's actually attached, I'm going to be able to change all 6 of these at one time. And the length of the dado, well, 13.125. And you can see it grew. So this is my dado. It's hanging out in space. It's not real. It looks like a real part. It is a real part. Notice it says blind dado. But I'm not done. Now I need to constrain 6 of these. 1 here, 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 and here. 6 of them constrained. Ugh. No. We developed a tool in woodwork design called Attach. And if I pick Attach and I touch it, you can preset these parts to ask you questions that allow everybody to constrain the same way. Okay, think about this. When you put a hinge in, always asks you the same way. When you put a drawer in, asks you the same way. Standardize. Do I want to put one at a time in? No. I want to put multiples in. Okay? It first asks you, select the end grain. Okay? And this is your own prompts, whatever you would like it to say. So I'm going to touch the end grain. Done. Select the top surface of panel A, panel B, and panel C. Done. And select the back surface. I'm just going to come over here and pick the back surface and then pick Attach. Done. All 3 of them simultaneously, and they're 100% and they're constrained. They're constrained. If I look at what that looks like, you could see here that instead of having mate and flush, in the browser, it's actually giving you that information right now. Those are the prompts that you were using. Okay, and let's do the other side also. Okay, so I pick Attach, I touch it, select the end grain. Okay, so the end grain. That. Select the top surface, 1, 2, and 3. Select the back surface. Doesn't matter where, just as long as it's correct. Back surface, because they're all lining up, right? There. And pick Attach. Let's take a look at what we just did. Those are 6 of them. All done. And the master, I don't need, so I throw it away. Okay, so what did I do here? Nothing magical. I basically took a part that was a template that's now unique to just this. So in other words, if I click on any of these right now, right, and I go ahead into iLogic and I say I want to change the dimension, let's make the dimension 12 inches deep, not 13, and hit return, they're all now 12 inches long and leaving me with a much deeper dado or blind. So, but that's up to you. Change the depth, how far into the panel, all those things are adjustable. Or if there's other things that you need adjustable, you can, of course, handle that. Okay. So let's now go back and turn on the left panel, the right panel, and the back panel, which nothing changed. If we take a look at this now, right, and rotate it, still nothing. So what can we do? Now, these particular units that I just built have key components to them. They have information on them. They have positive and negative shapes. The system understands what to do with them. So we developed a tool called Sculpt that looks at any of our library items. It doesn't matter where they come from. We've grabbed things from many other CAD systems. And I'm going to say Sculpt. And I pick Sculpt. It looks at the model, it looks at these key components, and it's now taking care of them. Now, in my browser tree, you could see that here are all of the 6. These are the 6 dados. Normally, I don't really need to see them, so I grab all of them, and I drag them, and I put them into my joinery folder. That way, they're out of the way, and they can be turned on and off if I want. And let's see what happened here. I'm going to just touch this panel, and I'm going to turn the visibility off. Look at that. It actually added that to the basic part. And if I went and do a bill of material with this, okay, let's look at the top panel. The top panel now is 54 inches, where it was 53.5 before. So my part list and my cut lists are right. Let's go further with this. Both sides are correct, of course. Let's turn the visibility off on that side. Both of them are correct. Okay, so now let's look at the right panel itself and see what happened there. I'm going to rotate the right panel out. There you are. Done. The CNC router will come right here and machine it 100%. And that's including clearances. All the clearances based on whatever your needs are already preset into it. Okay, so what happens? Okay, so now there's a change. Okay, here's the change. Horizontal panel, okay, is 6 inches. That's 6 inches from here to here. Let's make it 4 inches. Let's do an update. Okay, so we do an update. Interesting, huh? I'm in a 3D model in an assembly. Now it's working. Now what happened here? That's right. That data is still there until I say, you know, I want to sculpt again. And it looks at only the things that are there. It looks at only the things that are there, meaning the dados, and I'll sculpt. The old cutout goes away, and the new cutout gets generated. So there's no cross-part relationships here. I'm working in an assembly. It's fully controlled, and it's working the way I want it to work. What's also interesting about this is if I open this part, okay, you can see what we have. It's at the part level. Everything is at the parts level. Let's open up the side. the side is there too. Let's go back. That's the top, sorry. Let's grab the side. I'm going to right click and open it. Let's look at it. And you can see that's quite accurate. And then if I decide that I want to change it, do something to it, change it width, depth, height, very quick, all menus, standardize the way that you might want to work. If your design calls for more unique joinery, dovetails or Japanese joinery that show up that detail in furniture and some case goods, then again, utilizing the same system will work quite well for you, okay? So let's take a look at how that can be done. We basically go after it the same way. We say we want to create, let's do a slip dovetail. Okay, we're going to go into the same folder, grab it, and it's going to be a phantom part, and I pick OK and place it. Okay, so here's a slip dovetail, similar to a dado. Everything is adjustable, including the angle of the dovetail. Let's say the length is 15 1/8 to meet the needs. So that's changed, okay? But everything, again, is up to you what you want to adjust and how you build this. This form, again, is iLogic. If you take a look at any of our earlier YouTube presentations, we've gone over multiple ways of creating it. I'm not going to take the time at the moment. If someone has unique questions, please email us. Be happy to help any way we can. Okay, so now we want to use this and create slip dovetails on the verticals. Okay, so we'll pick attach, again, using iMates. Again, anybody who's not used to iMates, please do some research, plenty of YouTube stuff, or give us a call. Okay, so I want to put more than one in at a time. It says select the tail face, which is going to be the bottom surface. And of course, that's up to you how you want to tag it, okay? Select the side here and side here, and select the front face, which is going to be here. And I pick attach. So it's now put those dovetails in. Okay, let's do it again. Select the bottom surface. Because these are on two different planes, that's why I'm doing it at two different times. Select the surface here and here, and select the face here, and pick attach. And that's now done. And then I can do the reverse of it also. We can also do mirroring and all the normal things that you would do in Inventor. Really not much of a difference that way. Okay, Sculpt, and pick Sculpt. And that's now done. Let's take those 4 or 6 slip dovetails and move them into the joinery folder, just for housekeeping. And I'll just turn those guys off. And let's take a look at what we did. I'm going to right click on this and turn the visibility off. Boy, is that clean. And that's with a clearance. Let's take this, turn the visibility off. Again. Let's take this and open it into its own file. There you are. Done. Okay, let's turn these sides back on, left side and right side. Turn on their visibility. Turn on its visibility. Yep. And let's turn on the slip dovetails, because that's what makes it work. Turn on the visibility there. And what I'd like to do is move this panel left or right. Okay, so if I want to, vertical panel on the left-hand side is now going to move to 16 inches and do an update, leaving it behind. Okay, let's now go ahead and sculpt. Cleans it up like we just did, and we'll turn the visibility back off. Right mouse, and you can see it's totally adjusted. Accomplished our task. The reuse of data, whether it's libraries or hardware or fixtures or subsystems like drawers and doors, are an essential part of being able to reuse and speed up the process of design. There's many things that we use in a common way over and over again, even though the design of the entire system could be very unique. We buy hardware, and we assume that when we attach the hardware, it's going to attach to a certain mechanical way. So everything's not custom. So when we start thinking about joinery, okay, we can think of it in the same library way. Okay, what kind of joinery? Is it dowels or biscuits? Is it conformat screws? Is it knockdown fittings? And if it is, what does it look like? What does the negative shapes look like? What do the pilot holes look like? Okay, where do you put it? Where is it placed? How do you change it from one to the other? And if you're in a world that is constantly being modified, you want the ability to be able to jump from one to the other as quickly as possible and not start over. The goal is standardization and speed and accuracy, and that's what I'm hoping we can do utilizing some of the workflows that I'm showing you today. So when we look at a model like this, okay, you could see that in the wood world, what we're doing is we're adding material. This was flat across. The dado that I generated, the blind dado I generated, added material here and removed material there. That's really what happened. And when I move a shelf up and down, okay, and then resculpt, because the shelf's not there, it then heals what was and then creates new again. Simple concept, I think. And that's the process that we're really working with, at least at this stage. So let me do an update, put everything back. So let me show you how this all worked. File new, and I'm going to start with a standard part, and we're going to get started here. Now, everything that I'm doing here is a build-up from our first session and previous sessions. So if you haven't seen any of our previous presentations, they're all on youtube.com/WoodhamTech. Anybody have any questions, of course, you can contact us directly. Okay, so I'm in a new part file, and if I went into parameters, you could see that I already have 3 parameters defined: depth, thickness, and length, with nominal measurements that I have not really addressed at all. They really aren't doing anything at the moment because there's no geometry here. I also have an iLogic menu that is already hooked to that, so that when I start using it, the menu works immediately. Again, there are larger menus that you can see here that do a lot more, but that's completely up to you how you want to handle things, because everything is adjustable, you know, during the session, after the session. So there really is no limit, and you'll find your way, I'm sure, after a number of jobs, what makes the most sense. But again, standardization so everybody can do it in a similar fashion. So let's start by picking a rectangle. Let's start the rectangle like so. Let's dimension it. Okay, this value here I'm going to say is equal to depth. So I'll say list the parameter and pick depth and pick check mark, okay? This dimension here, when I place it, I want it to equal the variable thickness. So I hit this little arrow, list the parameter, and pick thickness, and that's done. I'll go into a isometric view and extrude this. I like extruding back into the part, like I've done there. And this is going to list the parameter, and that's going to be length. And pick OK. So I have my 3 parameters already done, and they are still controllable by my menu. So if I say that was 8 inches, it's going to 8 inches. If I say the thickness of this was 2 inches, it's 2 inches. So again, it's controllable. Don't have to go into sketches and start making all kinds of considerations there. Still will work, of course. Now, one thing is, this is going to be what I consider the actual tenon, okay? Really not a tenon, but if we rotate it, what you're seeing here is going to be this piece to where it stops. Because if I change the length, then I can have a blind dado. If I say it's the full length, then it's not a blind dado anymore, okay? And if I define steps or whatever, that's what they are. So what does your joint look like really determines what I'm about to do. Now, in the model, in the browser, you'll see something called solid bodies. And this solid here is referring to this first unit that I just created. So for this to be able to be added and be part of what it touches, I have to name this correctly. So I right click on it, go to properties, and I'm going to call it plus dado. Now, I don't care what you call it, it makes no difference to me. The only difference is that the plus sign is the key. The plus sign means add it. If this item encroaches at all onto the other piece, it will add. If it's flush, it will not add. If it's offset, it will not add. So it has to encroach by at least 0.001. Okay, so I pick OK, and that's the plus. Now, I'm going to create a work plane. I'm going to push it into the part, minus 0.01. And I put it at 0.01 just so you can see the difference. We look at it from a side view, and you can see that this work plane is 0.01 into the part, and that this plane will line up with the end grain of the shelf. Not here, because this is going to encroach in 0.01. Okay. Now, so we have the solid made. Let's make the cutout. So I'm going to flip it around the other way. I'm going to sketch on it. And I have an exact edge, exact size. And if I wanted a clearance, I could offset this, whatever the clearance would be, whatever I want it to be, and that's the physical hole that would be generated. Okay, in other words, if it's off 0.001, 1 mil, whatever, that's the clearance it would be. But if I wanted exact, I would extrude again. I would say extrude to the work plane, but I would say it's a new solid. That's the key, new solid, and pick OK. So I really have two solids sitting inside of each other, and you can see here in the browser it's called solid 6, or solid 5 or 3, whatever it was. If I right click on it and change its properties, instead of it calling it solid 6, I use a dash, meaning minus, okay, with whatever name you want to give it. I now named it minus cut. Okay, so one side will add and one side will remove. Okay, and then all of these still work just fine. Because it's adaptive to the original solid body, change one, it changes the other. So that's just the nature of Inventor. I'll pick File, I'll pick Save Copy As, Template. I'll put it here, I'll call it Sample 101, give it a name, and pick Save. And close out of it. Okay, I'm now ready to see how it might work. So we're at a point for testing. So I just removed the dados from the right-hand side. So let me open this up and take a look at it. So what I think I'd like to do is create a through dado through a sidewall. Okay, so again, once you have the know-how of building, you start thinking about construction in a different way. So I'm going to go ahead and say create. I'll grab the sample that we were using. I'll call it through dado. It is going to be a phantom part. And I'm going to hit OK and place it. I'm going to constrain it. So let's constrain this to this piece here. Apply. And I'll constrain that flush to here. And apply. I'll move this over a little bit. Okay. And I'll constrain it from here to here. Flush. And let's move it in 5 inches. And pick OK. Now, if I use it this way, it's going to be like a dado that we had already, you've already seen me do. But this time, what I'm going to do is go into iLogic, go into the dimension, and I'm going to say the depth of it is going to be 1 inch. And hit return. Now it's 1 inch. And I'm going to turn on the right panel. So the situation now is that it should actually cut right through that part. Exactly. Perfect location. And if I had tolerances and clearances, it would give me clearance all the way around. Let's see how this works. So I'll sculpt. Pick OK. And I'll take the through dado, put it into joinery, and turn it off. Let's rotate this and check it out, okay? So we'll go into a free rotate, take that board, again, hopefully you can see benefits all the way around in accomplishing these types of tasks. That way, build it simple, build it quick, make it efficient, add all the parametric information, then start adding all the different materials that are necessary, the different parts, the different assemblies, the different sub-assemblies. And what you have is a simple model that works very quick, no cross-part relationships, minimal crashing, minimal blowing it up when the sketches are too large. And this is just one of many techniques that we employ based on the type of design that we are dealing with. So I do hope that you enjoyed our session today. We look forward to presenting the next one, which will be before Christmas. I don't have the exact date in our continuing series of 4. This is our second one for the end of the year. If there are any questions or comments, or if you need any of the data associated with the things we did today, please contact us, email us. Again, thank you for your time today.